Cisco instructor Andrea here, and today I'm going to do a review of the protocol suites, paying particular attention to the OSI model along with the PDUs and explaining the term encapsulation. First of all, what is a protocol suite? A protocol suite is a set of related protocols that work together in the context of a larger stack. Now, what does that mean? Basically, when we're talking about how data moves through the network, we're talking about the way that it's moving through different layers or different stacks, and that at each of those layers, particular protocols will work at those layers. So it's just a way of describing all of these protocols that are kind of bundled together in these different layers. For example, the TCP IP protocol suite or the OSI protocol suite. This is the basis of what the internet is built on. It's a collection of related protocols that are used in various combinations to serve an application so that data can move through the internet or the network. An analogy of another type of suite might be Office 365. This is a suite of Microsoft products: Word, PowerPoint, Excel, etc. Microsoft has a suite of different products. You can use them individually or together. Another example might be the Google suite of products. Again, this is a little bit different than the actual OSI model or the TCP IP model. It's just to kind of get across the way in which these different products might work together and how they fall within a suite. Google has Documents, Google Sheets, Google Slides, Gmail, the search engine, etc. So these are products that Google offers as a suite of products. Another way just to think about the protocol suites might be an analogy of traffic or road rules for driving. When we're driving, there's signs that tell us how fast to go, tell us to yield, tell us to stop. There will be traffic lights, red, green, yellow. Maybe there will be train stops. So these are all things that work together to keep us safe so that we can move from point A to point B. Traffic rules and regulations. The protocol suites are more or less like that. The two most common protocol suites for the internet is the TCP IP model and the OSI model. Both of them do the same thing, and that is they describe the way data moves through the network from the source to the destination. The difference is basically history. The TCP IP model was designated in the 70s when the internet first started, and it is made up of 4 layers: the application layer, the transport layer, the internet layer, and the network access layer. The OSI model is the second iteration of protocol suites, and it is made up of 7 layers. Essentially, in the 70s, when the internet was very new, it was more or less very simplified. And so 4 layers would describe the way that traffic or data moved through the internet or through the data networks. As we began to advance and we started adding things like web conferencing, videos, being able to take and send pictures, emails, all of these variety of new services that were being offered on the internet, a 4-layer model no longer accurately described how to move data through the network. And so the OSI model was more or less designed or implemented in order to give more granularity to describe these new advancements in the internet. A protocol is something that enables your computer to communicate with one another. The TCP/IP model and the OSI model use the same protocols. It's just that they're going to function at different layers because remember, the TCP/IP model is a little bit more of a legacy model with only 4 layers, whereas the OSI model is the new iteration of a protocol suite with 7 layers. An example of a protocol, and maybe some you've heard of, would be HTTP, Ethernet, TCP, DHCP, DNS, IP, SSH, Telnet. There's a bunch of them. These are protocols that will have standards and regulations associated with them so that data and communication can happen between the source and the destination. Again, the 2 most common protocol suites would be the OSI model and the TCP/IP model. For this presentation, we're going to focus on the 7-layer OSI model. The OSI model has 7 layers: the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. Different protocols function at each layer, and each layer has a different job. The OSI model describes how data moves from a source device, let's say my computer, to the destination device through the layers of the internetwork. Again, let's just say my computer and I'm trying to send an email. That would be the destination. The OSI model will have 7 layers that function on my side, the source side, as well as the destination side. And then that's going to be connected with something called the media or the channel. And there's a lot of stuff that happens in between the source and the destination. Let's say I'm in Phoenix and I'm trying to send an email to Pennsylvania. Well, that channel is going to be represented by a lot of different things, and we're actually not going to be addressing any of that today. We're really just trying to get an understanding of what the 7 layers of the OSI model is and how the data moves through the network. Here's our email. It's going to move down through the OSI model, picking up information at each layer. It will move across the channel and it will start to go to the destination, where the items that were picked up on the source side will begin to be pulled off and then delivered to the destination. The OSI model is made up of 7 layers. That's the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. It's really important to just memorize these layers. The way that I did it is all people seem to need data processing. Now there's a bunch of other ones and you can even make up your own. At each layer, something different happens. And I typically talk about things from the top layer down. And again, I think of it in terms of maybe setting up or creating an email, and I'm going to interact with the application layer to start to type and write out that email. Different protocols work at each layer in order to help the data move from the source to the destination. Again, let's say I'm writing an email. So at the application layer, I'm going to be interacting perhaps with Google email. That is functioning at the application layer. once I write that email and I hit send, it's going to start to move through the different layers of the OSI model: the presentation, the session, the transport, the network, the data link, and the physical. Something different happens at each layer. Now, another reason that we have a layered model is so if there is an improvement in technology or a new technology is introduced, they can look at, well, what layer did this happen at? And just make changes to that layer without it affecting everything above or everything below. The other thing that's important about the layers is there are standards and regulations that are set. The easiest one for me to explain is perhaps at the physical layer. When I'm talking about cabling, there is a set of standards that set forth so that if a company wants to create a cable, they have to follow certain rules and regulations so that that cable will work in my computer, your computer, my next door neighbor's computer. Sure, they can come up with a proprietary type of cable, but overall, there are standards and regulations to protect the consumers from needing to buy a new cable or a new plug-in every single time there's a new iteration of a computer. It's the same thing with cell phones and the plugins. When there's a new iteration like USB-C, then all phones, all mobile phones, unless you're Apple, will have to accommodate that new standard. And that is designed to make technology innovation easier and more accommodating for the end user. Again, that's not to say that there can't be a proprietary cable out there. And this concept and idea works at every layer. If I am a software developer and I want to develop something that will work at the network layer is for IP. I have to make sure that it will take care of the existing IP. I can't just go in and say, well, I've just decided to make up something new and now everyone's going to have to change. Here again, we see I've created the email. The email will move through the layer. It crosses over the channel. And now it just reverses in order to get to the destination. In this example, I was sending an email to Pennsylvania. At the OSI model, the data will start at layer 7. For example, the email. The data moves through the layers and it picks up information that it needs in order to get to the final destination. At the presentation layer, for example, if I have included a picture, a PNG or a JPEG, or maybe an audio file, an MP3, that's something that happens at the presentation layer. Each layer has its own job. As the data moves down each layer, a process called encapsulation happens. That is the process that as the data moves to another layer, it gets wrapped up with some information that will be needed as it moves down the layers and then across the channel and over to the destination side. I'm going to go through a series of slides to show you this process of encapsulation. My slides are not the most professional, so bear with me and let me just see if I can explain the concept using these slides. So here I have my email, okay? And me typing an email, I'm going to say I'm using the Google application. And the application, presentation, and session layer is all happening at that email. And these three things are going to get packaged together. And when they're all packaged together and they're getting ready to start moving down the OSI model, they are called data. As the data moves down the layers, we give that data a new and different name because that is just a way to describe what it is called at that particular layer. So remember, right now I just wrote the email, everything's been packaged up, and this is the data. This is the group of things that's going to move down the layers to the other side to get to the Pennsylvania address email that I'm trying to send it to. Now that it's packaged up, it's going to move down the OSI model to the transport layer. And at the transport layer, it's going to get encapsulated. And remember, encapsulation is this process where I'm wrapping the data with information. This information is needed so that the data can actually move over to the source. What it picks up right here are port numbers, a source port and a destination port. Maybe you've seen like HTTP has a port number of 80, or HTTPS has a port number of 443. Well, now that this data has moved down, it's got encapsulated where it picked up port numbers. We're now going to call this the segment. Now, inside the segment is still the data. It's just that now it's wrapped up so that it can keep moving down the OSI model. The segment PDU, which is a protocol data unit, moves down the OSI model to the network layer. And at the network layer, it's going to pick up a source IP address and a destination IP address. Now, an IP address is needed to actually traverse the network to a remote location. Now that it has picked up the source and destination IP address, we call it a packet. The new PDU is called a packet. Now, it's picking up other stuff as well. I'm just giving you the primary things that it's picking up. And remember, inside this packet is still the data and the segment because I've wrapped it or encapsulated it with the source and destination IP address. I call it a packet. Now the packet PDU is going to move down the OSI model to the data link layer where it will pick up the source and destination MAC address. It's going to pick up the source and the destination MAC address. It's going to pick up some other things. It's going to pick up something called the control, and it's going to pick up something called the type. It's going to add a frame start and a frame end. But the most important things is it's going to pick up the source and the destination MAC address. Now remember, this process is called encapsulation. It gets encapsulated, and inside that encapsulation is the source MAC address and the destination MAC address. Now this new encapsulation, because remember, I've now encapsulated the packet had encapsulated the segment, and the segment had encapsulated the data. So that's now all stuffed inside of the frame. The frame is the name of the PDU at the data link layer, which is layer 2. Now the frame is going to move down. We're at the first layer, the last layer of the OSI model. There is no more encapsulation process. Now the frame is going to just get set down onto the physical media, the cable, the Ethernet, the fiber optic, whatever it is. And here it is in bits. We're looking at ones and zeros. And this is called the bits data protocol data unit, the bits. Now these bits are ready to be moved across the channel, and then on the other side, it's going to do the reverse of this. Before it can move across the channel, though, a process called encoding has to happen. Now, encoding is when the channel takes the bits, the ones and the zeros, and the zeros and the ones, and the 1110, and it transforms it into a format that can be carried over the media. For example, if it's fiber optic, those bits are going to be transformed into light, on and off, on, off, off. If it is Ethernet, it's going to be transformed into electricity, because the Ethernet cable doesn't understand ones and zeros, but it can understand electrical signals. So now the bits are going to be encoded, they're going to be put down onto the media, and they're going to move across the media to the destination. Now this exact same process in reverse will happen. The bits will be de-encoded and changed back from light into bits, and now it's at the data link layer. At the data link layer, it will be de-encapsulated, where the MAC addresses will be pulled off. Now it gets pushed up to the network layer. At the network layer, it will be de-encapsulated, where the IP addresses are peeled off. Now it gets pushed up to the transport layer. At the transport layer, the port numbers will be peeled off. And now it gets pushed up to the session, the presentation, and the application layer. And this is when the email is actually delivered to the destination and the receiver can open the email and read it. Let's recap the OSI model and the protocol data units. Remember, the OSI model is made up of 7 layers: the application, the presentation, the session. Those work together, and that's 7, 6, and 5. Then we have the transport layer, layer 4, that is the port numbers. We have the network layer, layer 3. This is where source and destination IP addressing happens. Then we have layer 2, the data link layer. This is where source and destination MAC address happens. And then we have the physical layer, layer 1. A mnemonic to remember this is: all people seem to need data processing. Next, what are the corresponding protocol data units, the PDUs? Remember, this is the name that we call the data as it's moving through the network. The first 7, 6, and 5, when those are all bunched up, that's called the data. The protocol data unit is called the data. As it moves down and it picks up the source and the destination ports, we call that protocol data unit the segment. Next, it gets pushed down to layer 3, the network layer, where it picks up the source and destination IP address. We call this protocol data unit the packet. After that, we move down to layer 2, the data link layer. Here, it picks up the source and destination MAC address, and this protocol data unit is called the frame. Lastly, the frame will be put down onto the media or the channel. It will undergo a process called encoding. And at the physical layer, the protocol data unit is called the bits. Now, a mnemonic that I use to remember the PDUs is: don't send pets for beer. Don't send pets for beer. Or you may prefer to remember it as do send pets for beer. I know I said it earlier, but basically different protocols work at the different layers. And each protocol has its own job. If we look at the application layer, we can see that some of the protocols that function at the application layer would be DNS, domain name server, HTTP, point-to-point, email, POP, SMTP, Telnet, FTP, file transfer protocol. Those are just a few of the protocols that function at the application layer. And then protocols that will function at the presentation layer will be HTML, doc, JPEG, PNG, MP3, MP4, things that you could think about that help the presentation of data. At the session layer, this is when a session is established so that the information can start to move from the source to the destination. TCP, SIP, RTP, RPC, different types of piping will be functioning at the session layer. This is where you would be opening up a WebEx session, for example, or allowing the WebEx session, or a session with Zoom. Next, we have the transport layer. At the transport layer, we have UDP, TCP, SSL, and TLS, and several others. Layer 3, this is our network layer. The network layer is where IP happens. IPv4, IPv6, IPsec, the ping, ICMP, also any of our dynamic routing protocols, OSPF, EIGRP, these are functioning at layer 3, the network layer. Layer 2. Layer 2 is where we've got the physical address or the MAC address. The MAC address will be picked up at layer 2. We also have HDLC, PPP, Ethernet. This is all happening at layer 2, the data link layer. Lastly, we have the physical layer. The physical layer is where the actual NIC card on our computers or our intermediary devices are working. This is where we're plugging a cable in. So 802.11, DSL, RJ45s are working here. Our RS232s for serial connections are working at layer 1. Why is understanding the OSI model and how data moves through the network important? Well, for one, if you're planning on taking the CCNA, there will be questions on the CCNA exam about the OSI model as well as the TCP/IP model. What happens at each layer? What are the PDUs at each layer? What protocols are functioning in each layer? But from a work perspective as a network administrator, understanding the way that data moves through the network is extremely helpful with troubleshooting. If you can begin to identify at what layer the trouble is happening at, you will be able to more directly begin the troubleshooting process and ideally fix that trouble quicker. It is very helpful when you're implementing any type of routine security or security period. For example, the data link layer, which is layer 2. This is where switches function. Well, there are particular types of vulnerabilities that can happen at layer 2. Well, as we begin to understand the protocols, we can also implement security measures to protect the switch. Same goes with layer 3, the network layer. As long as we understand the different types of trouble and or implementation of security that might happen at layer 3, we can create a more secure network. We will also be able to gather network data, and by understanding what happens at each layer, that will inform us what type of data to gather, as well as what does that data mean to us. And it will help in the implementation and design of new products and new software. The understanding of the OSI model is an integral part of understanding networking in general and fundamental to your journey for the CCNA. Well, thanks for listening. I hope this helped to explain the OSI model as well as the process of encapsulation, and remember de-encapsulation on the other side, and what each of those PDUs are.